Hello and welcome to another video of Grokking the Coding Interview. My name is Parth. In this series, we are going through the breadth first search approach. And in this video, we'll have a look at level order successor, which is classified as an easy problem. So let's go to the problem statement and try to understand what is required from us. Given a binary tree and a node, find the level order successor of the given node in the tree. The level order successor is the node that appears right after the given node in the level order traversal. So essentially, if we would traverse this tree from 1, 2, 3, 4, 5, and we are provided 3 as the key for this level order successor, we'll have to print out 4. If we are provided with 9, we have to print out 10. If we are provided with 12, we have to print out 7. So if you would do the level order traversal, whichever node you have been provided, you have to output the next node in that order in level order traversal. So how would we approach this problem? And the way I'm thinking of approaching it is actually a very simplistic way. So we'll do the level order traversal which we have been working on, and we will keep a flag which will be initialized to 4. And as soon as we find the key which has been provided, so in this case, for example, that key is 3. So as soon as we find that key in the tree, what we'll do is we'll flip that flag to true. And as soon as that flag is flipped to true, in the next step we'll just simply go ahead, so we'll check if that flag has been flipped true. As soon as that flag is true, we'll just go ahead and return the next element we encounter in that traversal. And it is how I'm thinking of implementing it. Let's go ahead and try to see if we can get a solution running. So if root is none, we simply return -1 here. We want a queue that will be initialized using the queue. We want to append the root into the queue right away. And the same standard exercise, we want to iterate through this queue until the queue is empty. At the first step, we want to know the size or the amount of nodes we want to iterate through. So essentially length of the queue. And here we'll also have a flag, which will be key matched, and we'll initialize it as false to start off with. Same exercise in range length of level size, and we'll get the current node, which will be q pop left, and we'll go ahead and simply keep everything as the level order traversal. Q dot append and current node left, if current node dot right, then we append it in the queue as well. Okay, so now one thing which we have to do is, if key has been matched, we simply return the current node, and we flip the key at the end of the for loop, so it'll only be reflected in the next element in that traversal. So if current node val equals to key, then we say key matched equals to not key matched, or you could also simply just initialize it to true. Otherwise, we just return -1. For example, in case the key is the final element in the traversal, in that case we wouldn't be able to provide anything in return. So let's quickly get started and see if our implementation is working fine. Okay. Let's see in case we are missing anything uh, here. Okay, we don't want length here. That's an error. 4, 10, 7. Let's quickly see what the answers were. 4, 10, 7. So it seems like our implementation is working fine. Let's speak about the runtime and space complexity of the implementation. Again, it would remain the same. The runtime will be off, and at max, we might have to traverse the entire tree and not find that key at all. And when it comes to space complexity, we have a queue which can at max hold n by 2 elements. Essentially, it'll have O of n space complexity as well. So I hope you found the explanation clear enough. Please let me know in case I can improve in any dimension. More than happy to answer your questions. Until the next video, enjoy your day.